the concept with spice and phasors is that you're given some sinusoidal steady state voltage input that looks like 1 cosine of omega t, or equivalently 1 cosine of 2 pi f t, where f is frequency in hertz, omega is frequency in radians per second. And you're sweeping that frequency. You're sweeping omega or you're sweeping f between different frequencies, and you want to find the magnitude, that VP of the output. So making it more concrete, you're always putting in something that looks like sinusoidal steady state, so it goes on forever in both directions. And the magnitude is 1. And what you're going to get out will be something that probably has a different phase. And it probably has a different VP. You want to know how the phase angle changes, and you want to know how the peak voltage changes as a function of frequency. So in this example that we gave before, it's reasonable to assume that at one frequency, we got this 0.136 at 71 degrees. At different frequencies, we'd get different magnitudes and different phases. And it would be a phenomenal amount of work to calculate this all by hand. But using SPICE, it's pretty straightforward. And so what we want to get out from SPICE is a graph that looks like this, that shows the magnitude over different frequencies, equivalent. It could be either omega or f. And as an example, this might be what it looks like for a low pass filter. For frequencies below about this, I'll call this critical frequency. It tends to pass it with about 1 volt, and for high frequencies, it tends to cut it down to about 0 volts. And similarly, you could create another graph that graphs the phase change, and we're putting in our signal, and maybe it starts off to be 0 degrees change, and over a period of time, maybe it changes it to be minus 90 degrees for high frequencies, just as an example. Let me give you a walkthrough about how to do this in SPICE.